Good morning, everyone. I'm Phương Pham. Welcome back to the course Food Waste Management. Today, we will start the second module of the study unit, which is about environmental impact assessment and management. This module focuses on understanding and assessing the environmental impact associated with food production, food loss, and waste across the food system. You will explore how this activity affects ecosystem, natural resources, and climate, and why reducing environmental footprints is essential for sustainable food systems. The module will help you strengthen competence in environmental assessment, life cycle thinking, and impact mitigation. The practical application include evaluating environmental footprints and applying a strategy to reduce food waste and environmental burden in agriculture, industrial, and business contexts. There are three learning outcomes in this module. In particular, you will be able to explain the environmental impact of food waste, loss, and production process on the ecosystem and natural resources. You will be able to identify effective strategy to reduce food waste and its environmental footprints. And finally, you will be able to assess product design and production method using established environmental sustainability criteria. This lesson is about environmental impact of food waste, loss, and production process on ecosystem and natural resources. Firstly, we will analyze the environmental impact of food production processes. The first thing that we have to consider is land use and habitat conversion. Food production uses more land than any other human activity. The practice like converting forest, wetlands, and grassland can disrupt soil, water cycle, and habitat connectivity, reducing natural ability to support carbon storage, water regulation, and wildlife. The deforestation occurs especially in tropical regions for soy, palm oil, and livestock. It can destroy habitat, isolate species, reduce genetic diversity, and weaken ecosystem function. Monoculture system is a common practice in agriculture. It simplifies landscape, reduces biodiversity, and increases vulnerability to pest, disease, and climate stress. Also, it can degrade soil, increasing dependence on synthetic input, reducing long-term ecological resilience. Soil degradation is another impact. Intensive farming can degrade soil, which is essential for plant growth, water regulation, and carbon storage. There are several types of degradation. Soil erosion in this phenomenon, excessive tillage, deforestation, and poor land management can expose the soil, causing it to be eroded by wind and water. When the nutrition-rich topsoil is removed, it leaves behind another layer which is harder and doesn't have much nutrients. In chemical degradation, the overuse of fertilizer acidifies soil and disrupts nutrients balance. Pesticide and herbicide also reduce microbiome diversity and slow down the key process like nutrient cell cycling and organic matter formation. The continuous cropping without restorative practice can deplete the soil organic carbon, reducing fertility, water retention, and erosion resistance. Agriculture uses about 70% of global freshwater, and food processing is also highly water intensive because there are the operations that use a lot of water, like washing and cooling, for example. Both contribute to water scarcity and pollution. The impact can come from water use or water pollution. Considering the water use, irrigation often exceeds the sustainable limit, depleting river and aquifer. The processing stage also have the operation that is very water intensive. That further strain local supply and impact aquatic ecosystem. Considering the water pollution, the runoff from fertilizer and pesticide causes eutrophication. This is a phenomenon where the nitrogen and phosphorus end up in the water body, causing the algal bloom that depletes the oxygen in water and harm aquatic life. The soil erosion also adds sediment to waterways. And finally, food processing effluents contain organic matter, oils, and chemicals that pollute the water. Both food production and processing are major contributors to global greenhouse gas emission due to land use change, livestock system, fertilizer use, energy-intensive processing, and transportation. The greenhouse gas include methane, which come from livestock and ripe paddy. In particular, the enteric fermentation in a ruminant can generate methane and anaerobic decomposition from ripe paddy because of the flooding condition, which is also a characteristic of ripe paddies. This gas has high warming potential. Nitrous oxide come from fertilized soil and manure and also poor nutrients management. This gas has extremely high global warming potential. And finally, we have carbon dioxide, which come from the deforestation, machinery, energy use in processing and transportation. Food production affects biodiversity through habitat loss, chemical use, pollution, and reduced genetic diversity. Considering the direct impact, clearing ecosystem for farm or processing facility destroy habitat, fragment landscape, and eliminate species. Pesticides can harm wrong touches like pollinators and other organisms. Processing related effluents can directly damage aquatic ecosystem also. What about indirect impacts? Use of uniform high-yield crop variety reduce genetic diversity. Trees and transport spread invasive species because these species can come together with the cargo and they can go far from the place of origin. Pollution from farm and processing facility degrade ecosystem far beyond production site. Now we will analyze the environmental impact of food loss and waste. Food loss and waste represent a major inefficiency in food system. When food is disposed, all resources dedicated to the production, processing, and transport are also wasted, increasing pressure on natural ecosystem. Considering the land use, when food is wasted, the farmland that was occupied for the primary production of its ingredient was used with no benefit. Since the land was occupied for production, It prevents the land from being conserved, restored, or used to support biodiversity. Agriculture uses about 70% of global freshwater. So, food waste means there's also wasted water. Since agriculture and also processing use water, even when the food lost early in the chain, it already requires irrigation and washing. About the energy use, fuel and electricity power farming, processing, refrigeration, and transport. When food is weighted, all this energy is weighted too, increasing emission without delivering nutritional value. Agricultural input, in particular fertilizer, require energy and other input for its production. So the synthetic input requires significant research and create environmental impact. When food is weighted, also these inputs are used unnecessarily, increasing pollution and resource depletion. Food waste and loss can generate greenhouse gas both from food production, no, which is upstream, and disposal, which is downstream. The upstream emission include all emission generated during farming, processing, packaging, transport, and retail. In cold chain energy use, fertilizer production, and machinery fuel are major contributors. About the downstream emission, when wasted food decomposes in landfill, it is in anaerobic condition. So it generates methane, which is one of the most potent greenhouse gases. Even with innovative gas capture system, the leakage of gas still occurs. Um, and besides the composting, which is an aerobic process, but if it is poorly managed, it can accidentally be in anaerobic condition that can generate also methane and nitrous oxide. Food waste in landfill not only can generate greenhouse gas but also contribute to both soil and water pollution. Uh, in soil pollution, the decomposing food generates leachate that which is contaminant liquid that contain organic acid, ammonia, and heavy metal. If the landfill liner is failed or is broken, this liquid can contaminate soil, damage soil organisms, and disrupt natural soil function. About water pollution, leachate itself can seep into groundwater, river, and lakes, introducing nutrients, toxin, and pathogen. This can lead to eutrophication, which is a phenomenon of contamination that, as I have mentioned before. Uh, thus, this phenomenon is a contamination, nutrients contamination. When nitrogen and phosphorus end up in water body, it can cause the algal bloom, which depletes the oxygen and harm aquatic ecosystem. It also threatens communities that rely on groundwater. Thank you for joining me in this lesson. In the next lesson, I will show you the strategy to minimize food waste and reduce its environmental footprints. See you next time.